Welcome to the last breakfast. Please enjoy the video.
You start by getting your class counts and converting them into probabilities. This is essential. First, list each class count and compute n, the total. Then divide each count by n to get pi for every class. Once done, pick the node or split you want to evaluate. That determines which subset's probabilities you'll use. Make sure to handle zero counts by keeping their pi as 0 rather than removing classes, because the formula expects a complete distribution. Now compute the index. For the chosen node, calculate the sum of squared probabilities and subtract that from 1. You square each pi, add those squares, and then do 1 minus that sum. For binary outcomes, this simplifies to 1 minus p squared minus 1p squared, which is quicker. Once done, interpret the result. Lower values mean purer nodes. Make sure to use the same probability set derived earlier and maintain numerical precision for small probabilities. To finish, compute the weighted Gini for a candidate split by multiplying each child node's Gini by its weight nj over parent n, then sum those weights. You compare weighted Gini across splits and choose the split with the lowest value. Once chosen, implement the split in your tree. If numbers look wrong, double-check that counts were partitioned correctly, watch for rounding errors, and confirm no class labels were misassigned. Because small mistakes in counts, change the index noticeably.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.